Using Excel to test a claim about a population standard deviation or population variance. This video uses the example titled, "Do Supermodel Heights Vary Less?" The sample data have been entered into column A, rows 1 through 16 in the Excel worksheet. The Excel stat add-in can be used to automatically generate the p-value, test statistic, and critical value using the following procedure. It is important to note that Excel stat requires a list of original sample data values and does not work with summary statistics alone. If only summary statistics are available, the Excel function chi-square.dist or chi-square.dist.rt can be used to find the p-value. Refer to the textbook for additional details on working with summary statistics. To use the Excel stat add-in to generate the p-value and test statistic, begin by clicking on the Excel stat tab in the ribbon. If Excel stat is not available, you must install it. Instructions for installing Excel add-ins can be found at the website www.triolastats.com. Click the Parametric Tests button in the Excel stat menu and then select One Sample Variance Test from the drop-down menu. The One Sample Variance Test dialog box now appears in Excel. The blinking cursor indicates the input item that is currently selected. Click on any input item in the dialog box to select it, or press the Tab key to move to the next input item. For the first input item, Data, enter the data range. In this example, we enter A1 through A16. Cells can also be selected by clicking on the first cell in the data range and dragging the cursor down to the last cell in the data range. Under Data Format, select one column per sample. If the data range includes a data label, check the Column Labels box. If there is no data label, uncheck the box. In this example, we do not check this box. Select Sheet to display the results on a new worksheet. Click the Options tab near the top of the dialog box. Under Alternative Hypothesis, select one of the three options for the alternative hypothesis. Select the first option, Variance 1 does not equal theoretical variance, for a two-tailed test. Select the second option, Variance 1 less than theoretical variance, for a left-tailed test. Select the third option, Variance 1 greater than theoretical variance, for a right-tailed test. For this example, we select the second option of Variance 1 less than theoretical variance for a left-tailed test. The selected item is highlighted in blue. Next, in the theoretical variance box, enter the claimed value of the population variance. This is the same value used in the null hypothesis. For this example, we enter 56.25. In the significance level box, enter the desired value. For this example, we enter 1 for a 1% significance level. Click OK to display the results. The p-value, test statistic, and critical values are displayed. The test statistic is identified as chi-square observed value. In this example, the results include the p-value for the left-tailed test of less than 0.0001. Because the p-value is less than the significance level of 0.01, we reject the null hypothesis. There is sufficient evidence to support the claim that female supermodels have heights with a standard deviation that is less than 7.5 centimeters for the population of women. Above the p-value, the critical chi-square value is provided. The critical value in this example is 5.229. The test statistic is provided directly above the critical value. In this example, the test statistic equals 0.907. Because the test statistic does fall within the critical region bounded by the critical value of 5.229, we reach the same conclusion that we reached using the p-value method.